So let's try graphing some of these items. Okay, so let's say we have the function y equals 3 sine 4x. We want to draw the graph of the function in radians and in degrees, clearly state the amplitude, clearly state the period. Alright, well, the magnitude of this leading coefficient, the magnitude of the leading coefficient is the amplitude. Alright, so in this case the amplitude is 3. Okay, now our period comes from over here, so our period, which is normally 2 pi, is now going to be compressed by a factor of 4, so our period then would be pi over 2. Okay. Now, example 4 on page 404 and example 5 on page 405 kind of help with this information. So we know our amplitude, so we know we're going to go all the way up to 3 units from our central axis and all the way down to negative 3 units from our central axis. Right? The period, 2 pi over 4, which is pi over 2. It's a sine function, so we know we start at the origin, right? And then at each period will be 0. But we also know that we're 0 at half of the period, right? So if we go halfway between the start and the end, we know that we're at 0 there as well. And then halfway between these will be maximums and minimums. I usually start going up. There's been no reflections here, so halfway between I'll be at a maximum, halfway between I'll be at a minimum, halfway between maximum, halfway between minimum, halfway between maximum, halfway between minimum, right? Halfway between max, halfway between min. So I know that those are going to be my points. Then I can come over here, right, and connect the dots so that one period, right, one period is pi over 2, right? Then I repeat another one, right, 0 to pi, I see 2 periods. Repeat again, and repeat one more time, right? So from 0 to 2 pi, right, from 0 to 2 pi is usually just one period, but in this case I see 1, 2, 3, 4, which lets me know that I compressed by a factor of 4, which is shown by this piece. I can do the exact same thing in degrees, right? Once again, always label your vertical axis, negative 3 to 3. Sine function starts at 0, right? If this, right, we know has an amplitude of 3, and we know we have a period of 360 degrees divided by 4, which is 90 degrees, then at my period, 0. Period again, 0. Period again, 0. Period again, 0. Halfway between the two, 0. Halfway between the two, halfway between the two, halfway between. Right? Then, halfway between two zeros, I'm either going to have a max or a min. Halfway between the two zeros, halfway between the two zeros, right? And I know that halfway between the two zeros, I'm going to have a maximum or a minimum. And I understand based on whether I open upwards or start going upwards or start going downwards, right? So here I am, up, down, positive slope, negative slope, positive slope, negative slope, positive slope, negative slope, positive slope. Alright? We want to make sure that, the points are clearly seen, the lines are nice and curved, right? It doesn't have to be perfect, right? But it needs to be close enough that we can clearly see where our maximums and our minimums are. We can clearly see where our intercepts are. We can clearly identify the period. Alright? So amplitude clearly identified, period clearly identified, and of course it even tells you that. Clearly state the amplitude and the period. Okay. These problems are very important that we can graph correctly. Please make sure you get the practice now.